Mm-hmm. Yeah.
Okay. Have you done this example, Zain?
Mm-hmm.
Have you done this example?
No, I'm working on it still.
It's not done.
Yeah.
So okay, we'll discuss it in class. Problem is use the graph to help you answer. Who was Barack Obama, who was first inaugurated at the age of 47 years 169 days, about 47.463 years, unusually wrong. Okay, what is the question? Okay, cumulative relative frequency of US presidents when they took office. A cumulative relative frequency graph can be used to describe the position of an individual value in the distribution or to locate a specific percentile of the distribution. Okay, so what's the question? Use the graph in figure 2.2 to help you answer each question. Was Barack Obama? 2.2, figure 2.2. Figure 2.2, it's down it. This is figure 2.2, yes.
Mm-hmm.
Was Barack Obama, who was first inaugurated at the age of 47 years, 169 days, unusually young. Actually, unusually young. Okay. So what he has done, age of
Because
inauguration,
presidents usually get inaugurated 50 years old.
he has taken 47, 45, 46, 40, 46, 47. Yes, 47 he has taken. 48, 49, 50. Yes, 47 he has taken. I'll take this on our board. What he has done, this is 46, 46, this is 47, this is 48, this is 49, and this was 47. So what did, he draw the perpendicular here, and same he marks a perpendicular on this. So this was 0, this was 10, and this was 12. So add 12. So what is the percentile? It's the 12th percentile. It's the 12th percentile. 12th percentile. So what was the question? I think so. So the question was unusually young. Yes, estimate and interpret the 65th percentile of the distribution. What we need to do is calculate the 65th percentile. So 65th, this is 70. So what I'll do, I'll draw a line here, and then I cannot draw exactly perpendicular, but I'll try to draw the perpendicular. I think it's 58 or 59, around 58 or 59. Yes, it's 58 or 59. See, I was correct. What we need to do is see the 65th percentile. This area, this one, this region represents percentile. I have told you in the morning, percentile, and this represents the ages. This represents the ages. So 65th percentile, I have drawn a perpendicular from 65th onto this uh, what you say, this curve, and then this I have taken this perpendicular down on the x-axis, and here it came to be 58. This was the thing. Okay. We have answered both the question. Now we'll move on to the next one. You can see this example. Okay, just read this question. I'll get back in 5 minutes. I'll just go to the washroom and come back. Okay, Said?
All right. Yeah.
I'm back.
Yep. Mm-hmm.
Yes. Okay. So, okay, about what? This is the interesting question. Shall I? Okay, we'll do it. Okay. Select the best answer. Mark receives a score report detailing his performance on a state-wise test. On the math section, on the math section, Mark earned a raw score of 39. which placed him
Mm-hmm.
at the 68th percentile. This means that Mark did the same as or better than about 39% of those who took the test. Means what he's telling? I think I should take this data. These are some interesting questions.
Mm-hmm.
So generally we have discussed in the morning what percentile means. That if I am calculating a percentile, I'm calculating the percentile. It's happening, man. Pen is not working. If we need to calculate the percentile, what is the main funda? That if this is 4 my point and I'm calculating the percentile of 4, so it is the data below or equal to 4. Below or equal to 4. Yes or no? Below or equal
Well,
to 4.
equal to 4.
Equal to 4.
Yeah.
So now what Mark earned a raw score of 39. So means the score of Mark is around 39. Okay. 30,
Mm-hmm.
30, 39. Okay. 39,
Mm-hmm.
and which is placed at the 68th percentile, and this point is the 68th percentile. So what does this mean? That 68, what does this mean? 68% of 68% of data data is below or equal to or equal to 39. Yes or no?
Mm-hmm.
Correct. So, which is the correct option? Mark did the same as or better than 39 of those. Means he is 39 or 39% those who took the test. This is wrong. Mark did worse than 39% of those who took the test. Wrong. Mark the same as or better than. Same as or better. So this is the line. This is the 68th. Okay, 68th.
Mm-hmm.
So better means this will be the better, na? So Mark did worse than better. Mark did same as or better than 68. But this answer will be correct. Mark did worse than about 68. Worse will come from here. So 100 minus 68 will be around 32. Yes. So see, Mark did worse about 32% of the data point. Yes or no? These are the 32. This is the 68%, and these are the 32 ones who had done 38 ones who had done better, who had done better. Yes or
I'm
no?
better.
Yes,
Yeah.
38%. Below 39 will be who had done better, and below 68 they are who had done worse than Mark, who had
Has done
done
worse.
worse than Mark. So 68. Mark has done 68% times better than these 68% data. So this is the thing. Okay, this C is the correct option. Did you got that, Zed? How to see?
Yeah, I got that. Yeah.
So next question. Mrs. Manson is concerned about how her daughter's height and weight compare with those of other girls of the same age. She uses an online calculator to determine her daughter is at the 87th percentile for weight and the 67th percentile for height. Explain to Mrs. Monson what these values mean. So we'll see. Tell her that 87 or the same. Her daughter Manson is 87%. What you'll say better, or his height is 87 at the 87th position in the whole data. Means there are 87% people who have height less than Manson. Yes or no? Or shall I plot it?
Yeah.
Is my reasoning
No, I
correct?
got it.
Yes, and the
Yeah, I got it.
67% of the girls have a height worse than Manson. Correct. That's the thing. Okay, so
Mm-hmm.
about what percent of calls lasted less than or equal to 30 minutes? About what percentile of calls lasted less than or equal to 30 minutes? 30 minutes, where is the 30 minutes? Less than or equal to 30 minutes. less than or equal to 30 minutes. So this is the 30-minute. Less than or equal to 30 minutes. So this is the 30th point. Okay, and how many total points are there? It is 0 to 45. Yes or no? The highest, I think. I'll look into the question what's highest. Yes, it's 45. So
Oh,
it will
okay.
be 45. We need to calculate the percentile, I think. Yes or no?
Mm-hmm. Yes.
So we need to calculate. We need to calculate the data points like that. No? So 30 is the thing. 30 divided by 45. So it will be around how much? 0 point. He has asked percent, not percent, not percentile. Equal to or more than 30 minutes. So it will be 30 divided by 45. So it will be 0 0.19. 9 ones are 9, 9 twos are 18, 9 threes are 27. 0 0.6 and 30. 0 0.66 means 66%. And what will be more than 30 minutes? This will be less. Less than or equal to. Less than or equal to. And what will be more than? So it will be the remaining part. That is 34%. But that's it. 100 minus 66. This will be 100 because this is 66%. So this will be 100 minus 66. So it will be 34%. Okay. Estimate
30%.
Q1, Q3, and IQR of the distribution of phone call length. So you can do this. Q1, Q2, Q3, and IQR. Come on. We'll move further. Now comes the Z score. So what's the Z score? What does Z score do? Measuring location. Okay. Also known as when we need to do standardization. Standardization means bring all the values of the data to bring all the columns to bring all the values in all the columns to a standardized form that's between 0 to 1, that is between 0 to 1, all the numerical values in all the quantitative columns to standardized form between 0 to 1 is known as known as standardization. This is standardization. Got that? So what we need to do to bring the values, them to bring them to standard form, we need to apply the Z score. We need to apply the Z score at each and specific value, at each and every value in the column. So I'll give you one example. Okay, so first of all, what is Z score? Z score, it is data point minus mean upon x minus mu upon sigma by root n. So it is given sigma, or what he has given? Standard deviation. Yes, sigma population mean. X minus mean upon sigma. So we can write it as this is a data point. In textbook he has given as value minus the mean of that column. Mean x bar. Mean of that column for which we are doing mean. Okay. upon standardization, upon standard deviation of the column, mean of column. So now we'll see one example. I think I'll give you one example, then we'll go on to the text. For example, there are two columns. Okay. For suppose there is weight and there is height. So these are our 5 observations. Likewise, just I am taking any figure, each 15. So, or I should not take 6, and I should take as again 7. Okay, and height I shall take 20, 35, 10, 10, 12, and it's around 25. Okay. So now what we need to do, I'll just do this next to it. Standard values. What I'm doing, standardization. Here I'm doing standard. Generally, this makes a different table, but I'm doing it here. So what first we need to do all these value standards. So what we need to first do, first we need to calculate the mean of this data. So what will be the mean of this data? I'll
I mean, I usually to give it, but okay. Let's do that.
uh,
Um,
5
how many
plus
values there are? Like 7, 8?
divided by how many observations are there? 1, 2, 3, 4, 5. Yes, 8.2.
5?
8.2, no?
Yeah, there is 5. Okay.
Okay, and how we'll calculate the standard deviation? We had learned the formula. What is the standard?
That divided by n, which is the number of terms.
No, it is x summation of x minus x bar, the whole square divided by, this is the what you say for sample it's n minus 1.
Yeah,
We
yeah.
need to calculate
The
this
x
column.
value minus the mean value
Correct.
squared
So we need to
n minus
calculate.
1 square root.
We need and then the square root also is correct. Then the square root also first, but we need to calculate this value first. Summation of this. So we need a column of this. See. Column x minus x bar. So it is 5 minus 8.2. I think it's 3.2. 5 minus 8 minus 5. It's 8 minus 8.2 is 0.2. Okay. And then 15 minus 8.2. 9, 9 and 6, 6.8. 6.8 and 6 minus 6.2. This will be 6 minus 1.2. I'm not considering the signs. 7 minus 7.2, 8.2. It's around 1 again. So 6 minus 2.8 is 2.2. And this is 1.2. Okay, so what I need to do the x minus x bar, the whole square. So what is the square of 3.2? So I need to calculate it. 3.2 into 3.2. 10.24. 10.24. Then 2 twos are 4. 2 twos are 4 is 0.04. 04. Then 6.8 into 6.8. 6.8 into 6.8 is 46.24. 46.24. 2.2 into 2.2. 2.2 into 2.2. 4.84. 4.84. 144. It will be 1.44. I think so. We'll see. 1.2 into 1.2. Right. So now we need to do the sum of all these values. Sum. We need to add all these values. Add all these values. So 1.10.24 plus 0.04 plus 46.24 plus 4.84 plus 1 plus 1.44. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. enter 62.8, and it's n minus 1 divided by, I think, 4. Yes, 4. 15.7, and taking square root of 15.7. So I'll write first the value here. So this is variance. This is sigma square. So sigma square come out to be 15.7. So I'll take the square root of sigma square. So that's sigma. So that will be root of 15.7. So what will be the root of 15.7? Or root of 15.7? It's 3.9623. So it's 3.96. So we had got the standard deviation 3.96. Okay. Now sigma is 3.96. Now this process starts. Now we can find the z-score of each and every data set. What we have to do? What is the formula? Value x minus x bar upon sigma. This is the z-score. So for first thing, I'll open the calci. Oh, where is the calculator went? Well, that's 5 minus 8.2. 5 minus 8.2 divided by 3.96. So it will be minus 0.808. Okay, it generally brings the value from -1 to +1. Okay, okay, okay. Then next is 8 minus 8.2. 8 minus 8.2. 8 minus 8.2 divided by 3.96. 3.96. It's minus 0.0505. That's now next is 15 minus 8.2. 8.2, enter, divided by 3.96. It is 1.7171. Then next is 6 minus 8.2. 8.2 divided by 3.96 minus 0.555. Now next it is 7 minus 8.2 divided by 3.96 minus 0.3030. That's the thing. These are the standard table of this. Got it, right? How to do it?
Yeah.
See, he has what he has done. Same thing. We had taken a dot plot. He had removed all the values from it. What is the minimum? What is the median? What is the maximum? What is the total number of data points there? Okay. Then he has done the summary. What is the question? Dot plot and summary statistics of the score of Mr. Tabor's first statistics text. Emmy's score of 43 is marked in red on the dot plot. Is marked in red on the dot plot. Okay. 43 is marked on the dot plot. Where does Emily's 43 fall in the distribution? Her standard score has standard score means the z score is, so what is the c score of 43? So it's 43 minus the mean is 35.44 divided by the standard deviation. It's 8.77. Yes or no? From here you can see it's standard deviation. So we get the z score of Emily's is 0.86. That is Emily's test score is 0.86 standard deviation above the mean score of the class. What does this mean? I'll explain in here. Okay, I'll just explain. The figure is not coming there. So this is our, what you may say, our normal distribution. Okay, this is for suppose our mean. This is for suppose our mean, and this is our standard deviation 1, SD1. So what does this mean? He's telling you that the Emily's test score is 0.86 standard deviation above the mean score of the class. So
Mhm.
if mean is here, so we need to go 0.86. 0.86 to the right side, 0.86% means
For
86%
it to reach 138,
to
it's to
reach
reach a
that
standard
score.
deviation.
Yes, standard deviation. So after going 86% to the right, we'll get the data point of Emily. Did you got that?
And,
Yeah. Okay, next.
and then we use that by doing mean minus the
Correct.
value minus mean
Upon
divided by
standard
standard
deviation.
deviation.
Yes, yes. Come on, read this question. Okay,
Huh? Okay.
I hope that you'll do this question in homework. Okay, it's simple. The Z score is very simple. Nothing. Okay, we'll do this one. Okay, no problem. Find and interpret the Z score for Jacob, who earned an 18 on the test. So is he given?
Mm-hmm.
Has he given the mean and all? Okay, no, he had given the mean upside here. Okay, so what's the answer? For Jacob, we have to calculate. So uh, the figure is not coming here. That's the problem. It came. Okay, I'll take the table also. Okay, we need to calculate the Z score for Jacob. His score is 18. So value, see, the pen is responding late. Value minus X bar, that's 30.5.44 divided by
Standard deviation.
standard deviation is 8.77. So what will
Mhm.
be the Z score?
Z score will be, let me check.
18 minus 35.44 divided by 8.77 means
Negative 1.98.
negative 1.98 means if I draw this.
Technically it's -2, but
So
let's
there are see. I'll complete the things, all the things here. When we are drawing a curve of a normal distribution, we are drawing the curve of the distribution. So there is a mean in between, okay, and then there's a mean in between, okay, and then there are distribution SD1, first standard deviation to the right, SD1. Then there is a second standard deviation to the left, second standard deviation to the left, second standard deviation to the right, and there's third standard. This is the third standard deviation at the corners, at the end corner, standard deviation 3. It's so we need to go. The first standard deviation we have to complete it full. and then we need to go the 98% around, likewise, for example, here. Cover this to the left. So this will be the Jacob's data point. Yes or no? Understood?
Mm-hmm. Yeah, understood.
Yes. The question is here only. Okay. Tamika had a standard score. So its the Z score is 0.292. Find Tamika's test score. So what we need to do, Z score is 0.292. So 0.292 equals to, it is a value minus mean. It's 35.44 upon 8.77. So we need to find x. What I'll do, well, let the x be here. Take this here. So it will be in multiplication 0.292 into 8.77. And then it will shift here. So it will get added to 35.44. So we'll do it on calci. 0.292 multiplied by 8.77 plus 35.44. It's around 38.004. So what is the score of Tamika? It is around 38. The score of Tamika is 38. The score of Tamika. Tamika, no? Tamika's. The score of Tamika is 38. Did you get that? How to do it?
Yeah,
38. Now next.
yeah, yeah.
Okay. See, 38. I told you. This you need to do for homework. This you will do
Mm-hmm.
as homework. Now next. Yes, transforming data. Okay. Okay. So I've told you, whenever we are doing standardization, whenever we are doing standardization, I'll come here. What we are generally doing, bringing the data in a range of, you can say, -3 to +3. You can say minus. You can The data will be generally in the range of -3 to +3 or less than that. So the value of 5 will be represented by some number between -3 to +3. So what was that value? It is minus 0.808. Correct? So means that -5 lies to the negative side of the mean. Means lies in the first standard deviation. Yes or no, right?
Mm-hmm.
Lies between mean and the first standard deviation, near about there. So this is how standardization is done. But what we are doing in standardization, we are subtracting the mean from the data point and dividing it by, and dividing. We are subtracting the mean from the data point and dividing it by standard deviation. Yes or no? So my question
Mm-hmm.
is, so the textbook is asking our question that when we are taking the data point and subtracting it from the mean and also dividing it by the standard deviation, so does it affect the distribution? Does it affect the distribution? Mean distribution means what? Subtracting, then adding, for suppose adding, multiplying, and dividing affects the distribution. This is the main question. Affects the distribution. So we'll get the answer to it. So the answer is no. The answer is no. If we do the Z score on a data, it does not affect the distribution. If it is skewed to right, it remains skewed to right. It does not changes. It doesn't become roughly symmetric. Okay. We'll see one example
Mm-hmm.
here. Okay. See, here he has given one example to find the standardized score, Z score of our individual observation. We transform this data value by subtracting the mean and dividing the difference by standard deviation. Transforming converts the observation from original units to measurement to a standardized scale. I've told you that what the standardized score, Z score, do? It converts the data points to a specific range, to a specific standardized scale. These are there are there are other reasons to transform the data. We may want to change the units of measurement for a data set. I've told you that if we want to change the units of measurement, bring all the units. I've given you that example. Weight in kilograms, weight in grams, correct? So if we want to bring all the values in a standard format, we need to do standardized scale. You remember that example, Zaid?
Yeah, yeah.
Yeah, so to change the unit of measurement for data sets from kilograms to pounds, this can also be used to Fahrenheit to Celsius, or perhaps measuring device is calibrated wrong. So we have to add a constant to each data value to get accurate measurements. What effect do these transformations? Okay, for example, if I'm telling in my data, in my data, now we have talked that subtracting and dividing
Yeah.
does not we have seen a z-score does not change the distribution, does not change the distribution.
Change the distribution.
Distribution, correct. Distribution. But he has, he's what he's telling, that we are noting something down in our column for some observation, and our machine, for example, 5.60 to 3.05, 10.115. Okay, so our machine was calculating 0.20 less, 0.20 less. So what
Mm,
will be the correct observation? It will be 2.40, 5.80. I've added 0.20 to each of the data. Yes or no? So will this
mhm.
affect our 35, 0.35? So when we'll plot the dot plot or the symmetric data for this, will this affect our symmetry when we have added 0.2? When we had added 0.2 to each of our observations, will have any effect on the distribution? He's asking us the question. So he'll answer us what is the funda behind it. Or perhaps measuring a device is calibrated wrong, so we had to add a constant to each data. See, we have added 0.2 to each data to get the accurate value measurement. What effect of these kinds of transformation, adding or subtracting, multiplying or dividing, have on the shape, center, and variability of the distribution? So, effect of adding or subtracting a constant. Recall that Mr. Tabor gave his class of 25 statistics students the first test worth 50 points. Here is the dot plot of the students. So here is the dot plot. So see what he has done. This was the original. This was the original. This is the original one. Now what he has done is done that he has added, I think. He has what he has done. Mr. Tabor was nice and added 5 points to each student's test score. How would this affect the distribution of the score? Shows graph and numerical summaries. Just we need to see how does it affect the what you say distribution of the score. The mean and all the thing will change. See, the mean has changed, but the standard deviation has remained the same because standard deviation
Yeah.
does not change. The variability, mark it down. Uh, adding constant. The standard deviation you have seen that remains the same. So variability has not changed. Variability, variability not changed. Okay.
Mm,
The mean will change, of course, because we are adding some constant to it. Then minimum has also changed. Minimum and this will also change. Q3 has changed. Maximum has changed. See the IQR range and IQR doesn't change. So IQR and range, which is a simple range, has not changed. Has not changed. Means what? What
range.
all
Yeah.
these values show? IQR, range, it all shows variability. Yes or no?
Yeah.
There are the tools to measure variability of the data. So this was the thing. So adding the same positive number A or subtracting A from the observation adds A to subtract A from measures the center and location. Means what? See here. If we had what you say, add 5, so the mean is affected by plus 5 if we are adding 5. Or if we had subtracted 5, then the mean would be less than 5. Yes or no, Zaid? He is telling this.
Yes.
The mean is 35.44. This is 40.44. That means mean also increases by 5. See, minimum also increases by 5. Maximum also increases by 5. What all is changing? They are increasing by 5. I'll take this. It will be very better if I take this on my board.
Yeah. I think I got it, at
You just
least.
paste it, na? We'll just paste it. For example, if you are referring the board for examination, so there will be a quick
Mm-hmm.
recap. So this is how I'll just mark it. This is changing by 5. Everything is changing by 5. Median also changes by 5. Q1 changes by 5. This was the thing. You got it. That's nice. Okay.
Mm-hmm.
You can write this in your book. Does not change the measures of variability, range, IQR, and standard deviation. Does not change the shape of the distribution. It also does not change the shape of the distribution here. It is leftly skewed, so it remains left skewed. Yes or no?
Mm-hmm.
Now the next is this thing was the shape of the distribution. What will be the shape of the distribution, right?
Shape of the distribution, it's gonna be right. It's skewed to the right.
Which is right, correct. Find the mean and median of the distribution of error. So what is the thing that soon after the metric system was introduced in Australia, a group of students was asked to guess the width of their classroom to the nearest meter. A dot plot of the data and some numerical summaries are shown. The actual width of room was 13 meters. We can examine the distribution of student errors by defining a new variable as follows: error guess equals to minus 13. Means there was a what you say. Note that a negative value for error indicates that a student guess for the width of the room was too small. So, okay, the actual width of the room was 13 meters. Okay, so this is the guess. So, this is the guess. So, what we need to do, we need to subtract a constant from it. So, what will be the mean? It's very simple. It will be more 13 less. So, the mean will be 3.02 for the new data. See, I've
So
told
two 3.02. Yeah.
3.02. I've told you the median also gets affected. So, the median is 2. Okay, so the
Uh-huh.
IQR and the range does not get affected. See the standard deviation and
It'll be
IQ.
exactly the same since it can only change by
Exactly. Yes.
multiplication.
Yes. That's good. That's good. You got that, man. You got that. Now also see the shape of shapes has also not changed. It is rightly skewed and it is rightly skewed here also. Did you got that? Our
Mm-hmm.
standardization. Okay. Now effect of multiplying or dividing by a constant. Multiplying or dividing each observation by the same positive number b multiplies or divides measures of central and location, mean and five number summary. This also has an effect. This multiplying and dividing. If we multiply or divide, it also has the same effect. Has the same effect effect as addition and subtraction. What was it affecting? It was affecting the mean, it was affecting the minimum, it was affecting the
Q1,
Q1,
Q3.
maximum, and it was not affecting the range and what you say and standard deviation.
QR, IQR.
IQR range and standard deviation. It was not affecting. The same
Mm-hmm.
is for this also. So you can see does not change the shape of the distributors also. Multiplies, divides measures of variability. Okay, by B. Okay, it changes. Multiplication, he's telling that it changes. So we'll see this tomorrow. Okay, see
Mm-hmm.
now multiply. Yeah, now there is a change in the things that in multiplication and division, this also changes. What does IQR range and what you say standard deviation also changes in multiplication and division
Mm-hmm.
the IQR, the range and standard deviation means the measure of variability. These are all measure of variability.
Variability.
Also changes means it gets changes means it gets multiplied or divided. If we are multiplying or dividing or divided by the constant which we, which with which we are doing that by the constant. That's fine. Did you got that right?
Mm-hmm. Yeah, I got that.
Yes, you can see this example as homework. So the next topic I think is that's the end of our topic. You can see the exercise questions here. There's quite interesting questions you can refer to. The next topic, I think what it is, density
is
curves and normal
bell
distribution.
curves.
Density curves and normal distribution, kernel density estimation. Okay. So we'll see
Mm-hmm.
this topic tomorrow, inshallah.
Yeah,
So I'll stop.
inshallah.
Assalamu alaikum wa rahmatullah. Take care.
Walaikum salam. Allah Hafiz.
Allah Hafiz.